Prague, the 27th of May, 1942. A black Mercedes staff car turns onto Holoshovich Street at 10:30 in the morning. Inside it sits Reinhard Heydrich, Reich Protector of Bohemia and Moravia, head of the SD, the man Adolf Hitler called the most dangerous in the Third Reich. His driver does not slow for the bend. He never reaches his destination. Two men are waiting at the curve. One raises a Sten Gun, a British submachine gun so crudely assembled that its receiver is a length of welded steel tube. Its stock a bent wire frame, its finish nothing more than bare, phosphated metal. It had been manufactured from raw materials to functioning weapon for the equivalent of £2 and 10 shillings. It had taken 11 man-hours to produce. It had no wooden furniture, no engraving, no proof mark from Birmingham or London. Nothing about it suggested it had been made by craftsmen. It had been made by a bicycle repair workshop in the English Midlands. The gun jams on the first burst. Heydrich dies anyway. From grenade fragments, from sepsis, from the consequences of a mission that succeeded despite the weapon. But the real story of the Sten Gun is not the jam in Prague. It is the story of what Britain was willing to build when the alternative was invasion, and what that decision unleashed on the world for the next half-century. To understand why the Sten exists, it is necessary to understand what happened on the beaches of Dunkirk between the 26th of May and the 4th of June 1940. In 9 days, the British Expeditionary Force evacuated 338,000 men from the coast of northern France. They left behind, on the sand and in the surf and in the fields between Lille and the sea, an estimated 68,000 tons of equipment: rifles, Bren guns, anti-tank guns, motorcycles, lorries, ammunition by the millions of rounds. The BEF returned to England alive. It returned almost entirely without weapons. Britain, in the summer of 1940, was an island that had just lost the equivalent of its entire standing army's small arms inventory. The War Office knew what the infantry needed. The industrial capacity to supply it, at the speed now required, did not exist in anything like the necessary form. The standard British infantry weapon at that point was the Lee Enfield No. 4, a bolt-action rifle of outstanding quality, manufactured at the Royal Small Arms Factory at Enfield Lock on the River Lee in Middlesex. The RSAF had been producing military arms on that site since 1816. It employed skilled precision workers. Its tolerances were exacting. Its output, even at wartime expansion, was measured in tens of thousands of units per month. The War Office needed hundreds of thousands. It needed them before the autumn, and it needed something that could also be manufactured outside Enfield, in engineering workshops, motor repair depots, bicycle factories, and light engineering firms that had never produced a firearm in their existence. What it needed was a weapon that could be built by people who had never built a weapon. The man tasked with producing it was Major Reginald Shepherd, a senior superintendent at the RSAF. Shepherd was not a famous name. He held no royal warrant. He had published no patents in the civilian trade. He was a government engineer, a man whose entire professional life had been spent inside the institutional framework of military procurement, working to tolerances specified by the Board of Ordnance and its successors, producing weapons for a war office that valued precision above cost. In the summer of 1940, everything that institutional framework valued was precisely what Britain could not afford. Working alongside Shepherd was Harold Turpin, a draftsman and design engineer at the RSAF whose name would be stamped permanently into the identity of the weapon they were about to create, though the historical record would be considerably less generous in crediting him for it. The designation Sten derives from their surnames and their place of work: Shepherd, Turpin, Enfield. It is one of the few instances in British firearms history where a weapon's name encodes not a founder's vanity, but a collaboration between two men who had perhaps 6 months to prevent a catastrophe. The brief Shepard and Turpin received from the War Office in the autumn of 1940 was unlike any brief issued to a British arms designer in the previous century. It did not specify materials. It did not require submission to the Birmingham or London proof houses. This was a military weapon, exempt from the civilian proofing obligations that had governed British commercial firearms since the Birmingham Gun Barrel Proof Act of 1868. It did not require a finished surface or fitted woodwork. It required 4 things: a weapon chambered for the 9mm parabellum cartridge, the same round used in the German MP40, which meant captured enemy ammunition could feed it in the field, a cyclic rate of roughly 550 rounds per minute, a magazine capacity sufficient for infantry use, and a unit cost that put it within reach of mass production in non-specialist facilities. The existing British submachine gun was the Lanchester, a near-direct copy of the German MP28, produced by the Sterling Armaments Company of Dagenham for the Royal Navy. It was well made. It had a solid brass magazine housing, a proper wooden stock, and a bayonet lug. It cost approximately £14 per unit to produce. It took over 150 man-hours to manufacture. Britain could not afford the Lanchester at the scale it now required. Shepard and Turpin produced their first prototype in approximately 5 weeks. The Sten Mark I was presented to the War Office Armaments Design Department in early 1941. The men who examined it were, by all accounts that survive, uncertain what they were looking at. The weapon measured approximately 76 centimeters in length, with the stock extended, roughly the same as the Thompson submachine gun then being purchased from the United States at approximately 45 pounds per unit. It weighed 3 kilograms unloaded. Its receiver, the central body of the weapon, the tube that contained the bolt and return spring and enclosed the firing mechanism, was a length of seamless mild steel tubing, approximately 32 millimeters in diameter, with a second tube welded at right angles to accept the magazine. The barrel was a steel cylinder, 196 millimeters long. The stock was a single length of welded steel rod, bent into an approximate shoulder shape. There was no pistol grip in the conventional sense. The forward magazine housing itself served as the grip for the non-firing hand. It operated on the simplest possible automatic principle, the blowback system. Blowback operation, in plain terms, the mechanism by which the energy of the fired cartridge pushes the bolt rearward against a return spring, which then drives the bolt forward to strip a fresh round from the magazine and chamber it, repeating the cycle as long as the trigger is depressed and ammunition remains. No rotating bolt, no tilting block, no gas piston. The Sten's bolt was a machined steel cylinder with a fixed firing pin. The entire lockwork consisted of a sear, a trigger, and a return spring. A trained fitter could field strip the weapon in under 30 seconds using no tools. The bolt could be replaced in the field from cannibalized parts. By official Ministry of Supply records of the period, the Sten Mark I cost approximately £2 and 10 shillings per unit to manufacture, against the Thompson's £45 and the Lanchester's £14. It required approximately 5 to 11 man-hours of production time, depending on the facility. It could be machined from steel tube stock available at any commercial engineering supplier in Britain. Its tolerances were deliberately set loose enough that parts made in different workshops could be assembled into a functioning weapon without fitting or adjustment. That last point was not a flaw. It was the entire engineering philosophy. The Mark I was followed almost immediately by the Mark II, the version that would define the weapon's wartime identity. The Mark I had retained a few concessions to conventional manufacture: a flash hider, a rudimentary foregrip, a rotating barrel jacket. The Mark II eliminated them. It reduced the weapon to its absolute mechanical minimum. The barrel jacket was removed entirely. The stock was simplified further. The magazine housing was fixed at a 90-degree angle to the receiver on the left side, a configuration that allowed the weapon to be fired from the prone position with the magazine pointing downward, and that gave the Sten its distinctive silhouette. Asymmetric, industrial, entirely unlovely. The Mark II went into production at the Birmingham Small Arms Company's Small Heath Works on Golden Hillock Road in Birmingham, the largest arms complex in the British Empire, which had spent the previous 40 years producing Lee Enfield receivers, Lewis gun components, and, between the wars, motorcycles and bicycles on the same factory floor. BSA, Small Heath, began Sten production in the spring of 1941. By the summer of that year, the Royal Ordnance Factory at Fazakerley, on the outskirts of Liverpool, had been tooled for Sten production. By autumn, the network of subcontractors producing components had expanded to include motor engineering workshops, light fabrication firms, and municipal repair depots across the Midlands and the North. The first significant combat deployment was to British airborne and commando units in 1941. The War Office placed an initial contract for over 100,000 weapons. By the end of 1942, that figure had been revised upward multiple times. The Sten was formally adopted as the standard British Army submachine gun, not because the War Office was entirely satisfied with it, but because it was the only weapon available in the quantities the situation demanded. The Ministry of Supply had not required it to pass through the Birmingham or London proof houses. Military weapons were exempt from the civilian proof obligation, the submission of each barrel to the proof house, where it would be fired with a deliberate overload charge to verify its structural integrity, receiving the proof mark only if it withstood that test without failure. Commercial firearms sold to civilians carried that legal guarantee. The Sten did not. The inspection and testing regime was conducted internally by the Royal Army Ordnance Corps at the point of acceptance. What the proof houses had spent 3 centuries guaranteeing for the civilian trade, the military handled within its own procurement structure. The Sten was, in this respect, entirely a state instrument. Born in a state institution, produced under state contract, inspected by state authority, carrying no mark that the worshipful company of gunmakers or the Birmingham proof house had ever touched it. It carried only the Enfield broad arrow proof mark, the government property stamp, and the receiver designation, Sten Mark II. Nothing else. Between 1941 and 1945, approximately 3.7 million Sten Gun guns were manufactured in Britain alone, with some estimates placing the figure closer to 4.6 million when Commonwealth and licensed production is included, though these higher figures require qualification against incomplete wartime records. The exact total is disputed. What is not disputed is the scale. To produce that volume, the Ministry of Supply authorized a production network unlike anything British arms manufacturing had previously assembled. BSA Small Heath was the largest single site. ROF Fazakerley was the largest purpose-built facility. But the Sten's defining characteristic, the looseness of its tolerances, the availability of its raw materials, the simplicity of its assembly sequence, meant that a significant portion of total production was carried out in workshops that had never held a Ministry of Supply arms contract before and would never hold one again. By official records of the Ministry of Supply's Small Arms Production Department, the peak production rate across all facilities reached approximately 47,000 weapons per week in 1943. 47,000 submachine guns every week, assembled from steel tube and wire and machined bolt bodies, proof-marked by military inspection rather than proof house, crated and shipped to units across every theater in which British and Commonwealth forces were engaged. The customer list was not a roster of regiments and Ordnance Corps depots. It was a map of the entire Allied war effort. The British Army received the majority of home production for infantry units, carried by signallers, vehicle crews, junior NCOs, and officers for whom the Lee Enfield was impractical at close quarters. The Royal Navy received allocations for boarding parties and shore defence. The Royal Air Force equipped its airfield defence units. The Home Guard, the civilian defence force of men too old or too young for regular service, received Sten Guns in large numbers. The weapon's simplicity making it one of the few practical options for units with minimal firearms training and no established ammunition supply chain. The Special Operations Executive, SOE, the British clandestine warfare organization established by Churchill in July 1940 to set Europe ablaze, received Stens by the planeload. The Sten was, for SOE, the ideal covert weapon, compact enough to be broken into 3 components and concealed in a suitcase, simple enough to be used by agents with limited small arms training, chambered for 9mm parabellum ammunition that could be sourced from German or Italian supplies in occupied territory. Between 1941 and 1945, the SOE airdropped an estimated 100,000 Sten guns to resistance movements across occupied Europe. The number is approximate. The records are incomplete, but the destinations are not in dispute. The French resistance received Stens, the Polish Home Army received Stens, the Yugoslav partisans under Tito received Stens. The Greek resistance groups, Communist Elas and Royalist IDIS alike, received Stens, occasionally in the same drop by the same aircraft, a fact that would later acquire considerable irony given what followed. The Danish resistance received Stens. The Norwegian Milorg received Stens. Every significant European partisan network that flew the Allied flag at any point between 1942 and 1945 carried, at some point, a weapon designed in 5 weeks at Enfield Lock from materials that could have been sourced from a plumbing supplier. The stakes of that supply chain were not abstract. If a Sten delivered to a Polish Home Army cell in Warsaw in the autumn of 1944 failed to fire, whether from the magazine feed issues that plagued early marks in dirty field conditions or from the ejector timing problems that caused occasional double feeds in the Mark II, a fighter defending a barricade in the Old Town with 1 magazine left had a weapon that might cycle for 20 rounds or might stop completely, with no armory within 500 kilometers to service it, and no replacement weapon coming until an aircraft could reach them through Luftwaffe night fighter coverage. The Sten's reliability problems were not a technical footnote. They were a matter of survival at the level of individual human beings in rooms that were running out of options. That tension between the weapon's inadequacy and the absolute impossibility of replacing it with anything better defines the Sten's wartime story more honestly than any production statistic. The Mark I IS addressed one specific operational requirement with a degree of engineering sophistication that its appearance entirely failed to advertise. The IIS, the S designation indicating the integral suppressor or silencer, incorporated a barrel ported with a series of holes along its length, reducing the propellant gas velocity before the projectile exited the muzzle, and a baffled suppressor body fitted coaxially around the barrel, reducing the weapon's report to approximately the sound of a heavy book dropped on a wooden floor. The Mark IIS was produced specifically for SOE and airborne special operations use. It was the weapon carried by Josef Gabčík, the Czechoslovak paratrooper who raised it at Heydrich's car on the Holešovice Bend on the 27th of May, 1942. It jammed. The mission succeeded through other means. The Mark IIS was subsequently refined. It went on to equip SAS and SOE operators in every occupied territory in which Britain maintained a covert presence. The wartime design cycle produced 6 principal marks, Mark I through Mark VI, each addressing specific operational deficiencies of the previous version, while maintaining the fundamental commitment to low-cost, high-volume production. The Mark III, introduced in 1943, reduced the parts count further and was manufactured as a near-seamless steel tube assembly that could be produced in under 60 minutes of machine time from raw stock. It was the cheapest and simplest firearm ever issued as a standard weapon by a major military power. Its unit cost, by Ministry of Supply records of that period, had fallen to approximately 10 shillings, half the price of a pair of Army-issue boots. The recognition came, eventually, in the form that wartime Britain offered its industrial workers. A King's Commendation for the BSA Small Heath production team, a Ministry of Munitions production certificate for ROF Fazer Curley, and a quiet note in the Director of Army Ordnance Service's annual report, acknowledging that small arms production had met its revised target for the first time since 1940. Shepard received a decoration. Turpin's name appears in the historical record with conspicuous infrequency. The weapon bore both their names, and history credited them unequally, in the manner that institutional histories often do when one man held a rank and the other held a drawing board. The Sten's decline was not the story of a company that ran out of orders. It was the story of a weapon that ran out of war, and then refused to stop. By the spring of 1945, the war in Europe was entering its final weeks. The Ministry of Supply began winding down Sten production contracts at the subcontractor network across the Midlands and the North. The bicycle firms and motor repair depots that had spent 4 years producing receiver tubes and bolt bodies returned to their peacetime trades. BSA, Small Heath, pivoted back to motorcycle and bicycle production. ROF, Fazakerley, shifted its output toward other ordnance requirements. The Sten, in the official procurement sense, was finished. The Army knew it needed a replacement. The Sten's magazine feed, which positioned the magazine to the left of the receiver in a horizontal orientation, had been a persistent source of field reliability problems throughout the war, the weight of the loaded magazine creating a tendency to pull the feed lips out of alignment, producing stoppages at the worst possible moments. The trigger mechanism, deliberately simplified to the point of minimal component count, had a safety arrangement, a notch in the receiver that held the bolt in a cocked but held position, that experienced users learned to respect and untrained users occasionally did not. Accidental discharges from dropped weapons were documented at a frequency that the Army Ordnance Corps preferred not to advertise. The Sterling submachine gun, designed by George William Patchett at the Sterling Armaments Company in Dagenham from a prototype submitted to the War Office in 1944, addressed the Sten's feed and safety problems with a curved 34-round magazine feeding from the left, a rotary striker safety, and an ejector arrangement that markedly improved reliability in field conditions. After extended trials at the Infantry Training Center and the School of Infantry at Warminster, the Sterling was formally adopted in 1953 as the L2A3, the standard British Army submachine gun. The Sten was declared obsolete. In official British procurement terms, the Sten ceased to exist. What happened outside those terms was considerably more complicated. The Sten's design had been distributed, under various wartime supply arrangements, to every Allied nation that needed it. The drawings were not classified at a level that made their post-war circulation impossible. The weapon's simplicity, the same simplicity that had made it producible in a bicycle workshop in Birmingham in 1941, made it equally producible in a bicycle workshop in Haifa or Belfast or Algiers or Hanoi, with no license, no proof house, and no correspondence with the Ministry of Supply. The structural force that destroyed most British arms manufacturers, legislative restriction, procurement shift, conglomerate acquisition, craft knowledge loss, did not apply to the Sten in any conventional form. The Sten was not owned by a company. It was owned by the Crown, and through the Crown, by no one and everyone simultaneously. Its design could not be recalled. It could not be protected by a commercial patent in the territories that mattered. It proliferated in the way that simple, effective, cheap technology, always for alls, proliferates when the institutional barriers to replication are removed. The Haganah, the Jewish paramilitary organization that would become the nucleus of the Israel Defense Forces, had been receiving SOE Sten drops in Palestine since 1943. In operations that the British authorities in the Mandate territory were officially unaware of and practically unable to prevent. By 1945, Haganah engineers in Tel Aviv had produced their own working copy of the Sten Mark II from hand-traced drawings of a weapon recovered from a British military disposal. The copy was manufactured in a clandestine workshop beneath a laundry on Hayarkon Street, using steel tube purchased from a commercial plumbing supplier in Jaffa. The weapons produced there, designated the Carl Gustav M/45 variant by historians who tracked their subsequent distribution, though the Haganah knew them simply as the Sten copy, were used in the 1948 Arab-Israeli War. They were subsequently passed on to other groups in other conflicts. The specific chain of custody defies complete reconstruction. The IRA manufactured Sten copies in domestic workshops in the Irish Republic and in Armagh and Tyrone from the late 1940s onward. EOK, the Greek Cypriot independence movement, produced copies during the Cyprus emergency. Vietnamese Viet Minh workshops produced 9mm tube weapons, functionally identical to the Sten Mark II during the First Indochina War. The MOD had retired the Sten. Nobody told the Sten. The last British Army Sten was withdrawn from service in 1960. The last Sten produced under any form of official Commonwealth license was manufactured in Canada in 1953. The last confirmed use of a Sten pattern weapon in an active conflict is not a date anyone can state with precision, because the weapon never passed through an official sunset. It simply continued. Contracts lapsed. Workshops closed. Records were not transferred. The drawing existed wherever someone had copied it. Shepard died in 1956. Turpin's date of death does not appear in standard reference works. The weapon outlived them both, in forms neither man had designed and neither government had sanctioned. There was no brand resurrection. No conglomerate bought the Sten name. No holding company registered the trademark. No auction house has ever offered an original Sten Mark II from the Small Heath production run under a collector's heading that commands the premium attached to a Purdy or a Holland & Holland. The Sten was never a brand in the commercial sense. It was a procurement instrument. When the procurement ended, the name passed into history without an heir. What the collector market offers instead is a document of industrial wartime Britain that no other firearm quite replicates. Original Sten Mark IIs from documented BSA, Small Heath or ROF, Fazer-Curley production appear at specialist militaria auctions. Holtz in particular handles significant quantities of deactivated British wartime small arms, where they command prices ranging from several hundred to several £1,000 depending on provenance, matching components, and accompanying paperwork. A Sten from a confirmed SOE supply lot with accompanying drop documentation occupies a different category entirely. The Imperial War Museum's collections at Lambeth hold production examples from multiple marks. The National Firearms Centre at Nottingham, the Pattern Room, holding the reference collection of almost every weapon ever submitted to British military trial, retains the original submission example from Shepard and Turpin's 1941 presentation, alongside the Mark IIs used in SOE operations. These are not displayed with the same reverence as a Purdy sidelock. They are displayed as evidence of what a country is capable of producing when it has no alternative. The Historical Breech-Loading Small Arms Association documents Sten variants as a category of particular academic interest precisely because the production dispersal means that no two Stens from different subcontractors are mechanically identical. The tolerances that were deliberately set loose enough for interoperability produced, as a side effect, an extraordinary range of minor variation in receiver dimensions, trigger group finish, and barrel specifications. To a collector or historian, each variation is a data point. To a military inspector in 1942, it was either acceptable or it was not, and the standard was set accordingly. Why does the original matter in a case where there was no original craftsman in any meaningful sense? The answer is more precise than it might appear. A Sten Mark IIs with its integral suppressor intact and its ported barrel confirmed original. Not a reproduction suppressor body fitted to a standard receiver, which the market also produces, demonstrates an engineering solution to a specific operational problem that the SOE's weapons officers worked out in deliberate collaboration with the RSAF Enfield design team. The porting pattern, the baffle design, the barrel thread specification. These were developed through trials conducted at a specific range at a specific location, producing a specific result that was then fixed in production drawings. The working original is the trial result, made permanent in metal. It cannot be reproduced in the relevant sense, because the trials that generated it cannot be repeated. The physical site of the Royal Small Arms Factory at Enfield Lock is now a residential development. The factory buildings were demolished progressively between 1988, when the MOD privatized and ultimately closed the works under the defense procurement reforms of the Thatcher government, and the 1990s. The site is known today as Enfield Island Village. Several hundred homes occupy the ground where Shepard and Turpin first assembled their prototype. A heritage interpretation panel at the entrance to the development notes the site's history. It is not always clearly legible. The River Lee still runs alongside it. B-A-E-S-A. Small Heath. Works on Golden Hillock Road survived in various reduced forms until its final closure in 2016. The site has subsequently been the subject of planning applications for mixed residential and commercial development. At the time of writing, portions of the original factory structure remain standing. The surprise that the Sten story reserves for the end is not about the weapon. It is about a laundry on Hayarkon Street in Tel Aviv in the winter of 1945, where a machinist named Yitzhak Sade's engineers were working from a hand-traced copy of a drawing that had begun as a 5-week emergency design exercise at a government facility on the River Lee in Middlesex. They were using steel tube from a plumbing merchant in Jaffa. They were building, without any contact with the British government, without any license, without any proof house, a weapon that would arm the fighters of the 1948 war. A war that would establish a state on a land that was then still technically administered by the same crown that had commissioned the weapon in the first place. The Sten had been designed to defend Britain from invasion. One of its first clandestine copies was used in a war against British mandatory authority. Shepard and Turpin had designed something they could not control from the moment they finished it, because they had designed it to be uncontrollable, manufacturable by anyone, anywhere, with materials available everywhere. That is the engineering legacy of the Sten. Not a company, not a royal warrant, not a Birmingham-proof mark or a South Audley Street address or a velvet-lined case with the maker's name in gold leaf on the lid. A set of tolerances deliberately set loose enough that the weapon could be built in a laundry, a cellar, a farm workshop, or a bicycle repair depot, by people who had never built a weapon before and who would build it again whenever the need arose, with or without Britain's permission. What Britain produced in its most desperate industrial hour was not a great gun. It was a replicable idea. The difference between those two things is the full distance between the world it was made in and the world it helped create. Music. The Sten Mark II IS at the National Firearms Centre in Nottingham sits in its display case with the suppressor body intact, the porting along the barrel still legible, the bolt drawn rearward against the return spring in the safe carry position, receiver stamped Sten Mark II. IIS broad arrow property mark, no Birmingham proof, no London proof, no royal warrant, no maker's name beyond the 2 initials of a major and a draftsman who finished their design in a building that no longer stands, on a river that still runs, in a country that has never quite decided whether what they made was a necessity, a masterpiece, or a warning. See you in the next one.